Robotics. We are at it again, and we're starting to write our code. As you see, we have it called AutoCar, right, or robot, and we call it AutoCar because it's an autonomous system. We're writing the program for autonomous system. We're trying to test something. It's an experiment. So these are libraries that we are adding, and we're going to explain what these libraries for. But these are libraries, and we're going to start writing our code because we're going to add the pins that we're going to use on the computer for ultrasonic sensor. So that's our robot there. We use some box. We use some cardboard box, and that cardboard box is for us to mount the ultrasonic sensor on another servo. So there is a servo below there that deals with the ultrasonic sensor, and then of course we have our camera unit, right? It is a ribbon cable that connects the camera unit to our computer or onboard computer. We have some other devices and so on that way. But however, this is supposed to be our autonomous car. So it's supposed to track colors, track balls, track multiple objects. So we're gonna do some machine learning, artificial intelligence. But first of all, we're gonna get it to move autonomously, which is these lines of code we're gonna write here. Probably about, I don't know, about 100 lines of code. And then we're gonna add the camera units and all those things into it. So we're gonna keep you updated on that. This here is our robot car. Again, some makeshift stuff. You can see the cardboard. We tear some cardboard box so that we can mount the sensors. We have a camera mounted there. We have some stuff. So that's mounted there. And this, of course, let's go back to the car. So that little red, that green thing there that the ribbon cable is connected to, that's lighting up there. That's the onboard computer. It's a microcomputer, very powerful microcomputer called Raspberry Pi. But we remotely connected to that computer here on our machine, and we were using the laptop keyboard to actually function, or instead of connecting a screen and so on to that, we just remotely connecting to it using something called VNC viewer. Right, so you can see it up there, VNC viewer, right? So we're able to connect to it. However, our files that we're using, we create a file called robot, and in here we have some other python.py. These are Python files. So let's say, for example, the ultrasonic sensor. We have the ultrasonic sensor, the code that we write to control our ultrasonic sensor. We have it inside of here. So we have all the libraries. So we import RPI, which is the GPIO pins, as GPIO, which is your GPIO pins. You import a library from our library called time, and then of course this are probably a few lines of code. Let's see how much lines of code we just. We wrote this night before, but anyway, let's do some probably about 50 lines of code, so 60, right? So all this does is it checks and calculates, because it's an ultrasonic sensor. So what the ultrasonic sensor is, the ultrasonic sensor has two ports. Let's see if we see an ultrasonic sensor here. So in this car here, we also has an ultrasonic sensor, but it's not connected. So in front of this ultrasonic sensor, there is two devices here, and one of these devices sends out a sound, and it probably goes out. That sound goes out, traveling at the speed of sound, and bounces off of any objects, and it comes back. And what we do, we calculate the time it takes to come back, which allow us to calculate how far the object is from the front of our robot. And what we do, so we calculating that. So we write some code here, and we're going to explain this when we have one more time, but it allows us, there's this function we create here called getDistance, which allows us to track the time that it takes for our ultrasonic sensor to get the response. And once it tracks that time, we're able to look at the echo. So it is the echo or the bounce back. So that's all that setting up. So as you come here, we can see how it's able to calculate the distance. Of course, up here we are setting the time, and we are setting the time, and we are setting the pins that will allow us to turn off and on, because this sensor, this ultrasonic sensor, is on a servo. We haven't incorporated the servo into our code as yet. We're just testing the ultrasonic sensor, so we're just interested in the ultrasonic sensor. So but in the back of it, there is 4 pins in the back here, which allows us to trigger the ultrasonic sensor to send out the signal. One that allows us to receive the signal, the sound signal when it bounces back, and power on ground. So power on ground goes to our power supply on the computer, 5 volts power, and the trigger and the receiving of the sound. We set pins on the computer to receive that. One to trigger it, so the computer automatically triggers it to see what's in front of it. And then of course we have the and of course we have when it will calculate the distance using the speed of sound, time elapsed. So you have the speed of sound, which is 34,200. Right, we cover of course centimeters per second. Return distance, that's when it bounces back, and of course once we get that information, we're able to calculate that. We're going to use a while loop to give us, it's going to run and it's going to give us the distance. It's going to utilize the distance if the distance is greater than 30 centimeters, because of course we translated it to centimeters, right? So centimeters is going to be obstacle detected if anything within a 30 centimeters radius, and of course if it's not within a 30 centimeters, it should print out the all clear. And we're able to run this, clean up the GPIO off. We're going to explain all of this and why it's done. Of course, we're going to explain also how ultrasonic sensors work, which is going to give you a fair idea on why we implement true code, why we implement it to run the way in which it runs. So again, understanding the basic sensors and components of a robot gives you advanced insight into how you expect to actually go about the algorithms. Yep. So again, let's look at it. So my camera screen is kind of crazy right now, but again, this is the importance. As again, we have our robot, we have power supplied to our robot. So if you can see here, that's the Wi-Fi dongle that allows it to connect to our system remotely. So you're remotely connected. So here again, these are the libraries we import, and we'll talk about this a lot more. But these libraries are libraries that support our code. We have the pins, the ultrasonic pins. We use what this part of the code is telling us is we're using a trigger and an echo. We talk about the ultrasonic sensor. We say that these were two: one that sends out a sound or ultrasound, and it's bounce obstacle, and which bounces back. It's collected here, and the other one, and it allows it to calculate the distance, what distance is from the front of our robot. So we set the pins for that. And of course we have our motor pins, which allows us to get these are the 4 pins, motor controllers, and then of course set up all these pins. And then we have motor 1, motor 2, because we have 2 motors this robot is using. We're going to show you what we did. This is another robot here, right? But this robot has 2 wheels, right? 2 wheels, which is 4 wheels. However, this robot here just has 1 wheel on either side, which gives it 2 wheels. So what we're going to do, we are defining, so we created a function here, and this function allows us, and we're going to call this function back. So we pass some parameters, which is the speed parameter, and we're going to define speed as we go along. So it allows us to create an output for IN1 and IN2, which allows IN1 to go high. As we know, computers runs on 1 and 0, ones and zeros, right? We call these 1s and 0 systems. These are 2 systems, 2 or bi systems that they use. So 1s and 0s, the language of computers. And when we say high, that's 1, and of course we say GPIO low, that's 0, means it turns off the pin 2. And this is using something called PWM, or pulse width modulation. So it turns off 1, turns on 2. This allows the motor to go forward. So it's going to go forward. This is motor 1 forward, and of course motor 1 backward. We reverse it. So we send this pin IN1 low or off, and we allow pin 2 to go high. Once we do that, as we're talking about, setting the pin high and low, as backward we say it's in a reverse direction compared to forward. So it reverses the motor itself and allows the motor to go in the reverse direction. We do that for the two motors, so we end up with 4 signals. And then of course we have where the motors can stop. So we stop all the motors by basically turning the PWM signal, pulse width modulation, turn them to all 0. All goes to low or 0 means all the motor is going to be off, and that allows us to have the motors off. Now what we're doing in this case is the fact if we look at up here, we set our trigger and so on. That's with the ultrasonic sensor. So what we're trying to do is we're trying to get the robot, right, is the ultrasonic sensor. We're trying to get the robot to calculate obstacles in front of it, right? So we have to get it to go left and right now. So it's going to ID obstacles a certain distance from it, and it's going to be able to maneuver away from it, either going left, right, stop, go forward, go back, and it's going to make these decisions autonomously, meaning that there's not going to be any human interference, there's not going to be no remote control or anything. It's going to be in an environment, and it's going to determine where the obstacles are and move away from them. And as we see programming, whether it's be in Python, we're using Python here because Python is a lot easier for beginners. That's 1. 2, it's open source. 3, a lot of our artificial intelligence, a lot of the models that we look at, it's already written in Python. So it's easy to find information and find things that we can use. And of course, artificial intelligence and embedded systems, it's predominantly, but it's not all, but predominantly in Python. And we're going to be using a lot of machine learning models, artificial intelligence, in our robots as we go forward. But these are the basic, these are the wrong building blocks. And building blocks is to understand sensors, understand how these sensors work, understand some electronics and how these electronics work, but most importantly, understanding how we're going to implement these things through code, programming. And that's the only way computers is going to become intelligent. When you talk about intelligence, we'll have to command computers, because computers are really dumb. So you'll have to command them to do what you want them to do. Of course, they're going to read sensors, they're going to read and tell the actuators what to do, but there must be some commands to allow them to make those type of decisions, and there's where you come in as a programmer. Programming, we're talking about computers, and we're talking about computers and computer intelligence. These are something important, and a lot of times when we talk about programming, we're talking about computer language. Computer language, again, as we say, is speaking binary code, and binary means just by 2 numbers nary, because you're using 2 numbers, 1s and 0s, and this is why as we look at our code here, it's just simply us allowing 1 to go high, 1, and 1 to go low, 0, and that's all it takes for us to control our motors, to allow the motor to make a direction. We switch it, as we reverse it, of course the motor is going to go the other way. It's commanding the robot to make decisions, and that's important as we look at another microcontroller, one other microcomputer, and we look at what we call the header pins, or your input output pins. A lot of times these input output pins allow us to connect various sensors, or in these cases or breadboard LEDs, and it allows us to connect it directly to the computer, and the computer create the commands or send the commands, what it should turn on, what it should turn off, what it should read from, what instructions it should carry out based on these readings from these sensors, and all based on what you program it to do.